Hello everyone, welcome to Geeks for Geeks. So let's talk about today's problem. Our problem name is count ways to nth stairs, right? So the question is there are nth stairs and a person is standing at the bottom and want to reach at the top, right? So the person can climb either one stairs or two stairs, right? These are the two possibilities. So we just have to count the number of ways that the person can reach the top, right? So its source will be at the bottom and I just want to reach my destination will be at the top, right? That's what. So we just have to count how many possibilities the person can reach at the top, right? So in that case, the node point is given to us. Order doesn't matter, right? So if you have couple of orders, right? If you have couple of answers to reach from bottom to top, but that particular having the same numbers, right? For example, here n equal to 4, we have three possibilities. The one will be 1 to 1, 2 1 1 and 1 1 2. If you see in this case, we have 2 times 1 and 1 time 2 will be occurred, but order will be different. But in that case, if that thing will be came now, we just have to count that particular thing only one time, right? Okay, that's what they want to tell us, right? So if n equal to 4, the output is 3 as given in the example, and equal to 5, we have 3 output, right? So in that case, let's see how we can solve this. So the question said you are at the bottom, want to reach at the top, right? So if I write like this, right, this is bottom, okay, and you want to reach the top, right? So vice versa, you can say that you are at top and just want to reach the bottom, right? This idea is also good, right? So in that case, let's see. Right now my n will be 4, right? So okay, so my n will be 4. So if you see the previous question, it's a bit of same, right? So for example, n equal to 4, in that case we have two possibilities. The one will be go to the one step back and other will be the two step back, right? And here also we have one step back and here we have two step back, right? Here we have one step back, here we have two step back, right? Here we have one step back, here we have two step back, right? So this is the recursive tree of it, right? If you see here, when we reach to the 0, it means that particular thing will be your answer, right? Okay, so it means one step, one step, one step, one step. So this is the first case, 1 1 1 1, through which we can reach to the bottom or top, right, where you are starting. In that case we are not able to do that, right? Okay, if you see, let's see for this case. If you see, this is first step and this is the second step and this is the third step. So in this case my answer will be two step, one step and one step, right? This is also 4, like that. Okay, so if you move forward, like here you have, so take one step, here we have take two step. In that case we have 1, we have 2 and we have 1, right? So 1 2 1, like that. Okay, in that case we have 4. But if you see for this case, let's do for this case, it's not right. In this case, if you have f of 2, okay, in that case you have one step, you have two step, right? So in this case also you are going one step back, you are going two step back, right? So in this case one step, right? And here we have two steps. So let's write here one step and two step. This is also equal to 4. In this case 2 and 2. So in this case we have 2 and 2, right? So these are the 5 possibilities, but the question said these 3 are same. Please add that particular 3 one time, right? Okay, so we just include first one and this one will be the second and this one will be the third, right? So my output in this case will be 3. But if the order doesn't matter, is not given to us, the answer will be 5. But in that case, what you have to do is you can solve that particular problem using backtracking, right? Take all the possible ways and make a set of it so that that particular set contains only the values in one time, right? So we just have to take like that. Key 1 1 1 will be added in my set. After that, set of vectors, right? And other will be 1 1 2, right? And other will be 2 2. So we just have to count what is the size of that particular set of vectors. It's 3, output is 3, but that takes a lot of time to solve that, right? But if you see the constraint part, so question said you have to solve that particular problem in order of n, right? So how we can solve the problem in order of n? Let's see it, right? So let's see the pattern to solve that problem. Okay, so if you have, for example, f of 1, right? So in this case, how many possibilities? 1, right? We are at the 1 stairs. I just want to reach the 0th. We have only one possibility. Okay, when we have r at 2, how many possibilities we have. Let's see in this case. So either go to one step back, either go to two step back. In that case, either go to one step back, either go to two step back. So in this case, one and two. That's the two possibilities, right? So if you do the same thing for the three, we given the two part, right? Which is like a common part, right? If the common will be given to us, we just have to ignore that part, take only once occurrence of that, right? So if you take the n equal to 4, that will be 3, which is given to in output, right? Sample inputs, right? If f equal to 5, that will also given in the question, that will be the 3 part, right? Okay, okay. Now after that, when we are at f of 6, right? So if you see what's my answer in this case, my answer is, let's see what's my answer. If I take the sample input, let's take what is it, the example of it, right? What's the output in this case? Okay, the answer will be 4. Okay, let's write here f4, right? It's like this. Now what I want to tell you is, okay, let's see the pattern into it. So let's take the example of f of 6, right? So if you see here, if I go, this will be same, right? And if you take f of 7, this will also same. If you take f of 8, it will be 5. So if you take this particular part, this will be 1 plus what is f of 4, right? What is f of 4? So that's the pattern of it, right? So if I calculate f of 4, that will be 1 plus what is your f of 2, like that, right? So if I want to calculate f of 2, what is that pattern? 1 plus 2 step back, right? But here I want 2, right? So 2, we just have to go 1 step back, 2 step back, that particular answer will be 1. 1 plus 1 plus 2, that's the pattern of it, right? So let's see for it. So f of 6, I just want to calculate. As I tell you, what you have to do is, you just have to add 1, right? So this is a pattern which you have to focus here. 1 plus, go 2 step back. What is that? That will be your 4, right? Okay, now after that, 1 plus, go 2 step back, that will be 2. 1 plus f of 0. So in that case, if you see this part, I want f of 2 will be 2, right? So if you write the recursive call, my base case will be, if n equals to 0 now, you have to return 1 in that case, right? Else what I'm doing is, I simply return 1 plus and going 2 step back, like this, right? Okay, now so in this case, my output will be 1 and 1 plus 1 will be 2, right? Yeah, it is correct. And what is f of 4? That will be 3. So let's write here 3. And what is f of 6? That will be 4. That's also correct, right? Okay, now let's see for the odd case. So for example, if f of 5 will be given to us, what we have to do is 1 plus, go 2 step back, that will be this. 1 plus, go 2 step back, that will be this. 1 plus, go 2 step back. So in that case, it goes to the negative part, right? So what I'm doing is, I simply stop here. Now we know that what is f of 1, that will be 1. So let's return here 1. So in that case, I just have to modify a bit of my code. Here I just write, if n equal to 1 now, in that case also you just have to return 1, right? Okay, so that will give to 2, that will give to 3. That's what I want here, right? Okay, so that's the idea to solve this problem, right? So that particular backtracking take a lot of time, right? Take a set of vector, right? But the idea to solve in under sorry, please cut this. Idea to solve that particular problem in order of n, that's the approach, right? We just have to take the pattern, how the pattern is working, right? So let's code now. So in this case, what I'm doing is, I simply write, if n is 0 or n is 1, right? In that case, simply return 1, right? Okay, else what I'm doing is, I simply write 1 plus, right? And let's call this function, that will be n by 2, n minus 2, like that. So this is the two-step problem, right? So let's see it's working fine or not. Yeah, let's submit and check. Yeah, it's correct, it's working fine, right? So what's the time complexity of the solution? We go 2 step back, 2 step back, 2 step back. So if you see, that particular problem will be solved under log or order of n, right? The complexity will be order of n, right? So we can also convert that particular problem into dp, right? So if you don't want to convert into your recursive part, so how we can do that? We know that, let's make here dp of size n plus 1, right? Like that. And dp of 0 will be 1 and dp of 1 will be 1, like this. And we just have to traverse from 2, right, till n I plus plus. So what is my dp of I? That is 1 plus, go to 2 step back, right? That is dp of I minus 2. right, like that. Okay, and return whatever you are storing in dp of n, like this, right? Let's submit, compile and check once. Yeah, it's working. Yes, it's working fine, right? So in that case, what's my time complexity? Order of n. What's my space? Order of n, right? So hope you understand the solution intuition. Thank you so much.